trying to get it all synced up. Yeah, no swearing today. Let me know when we're looking good. Robin, are you able to check if it's on both platforms?
Well, it is like
yeah. And Patty, do you need access to the internet, right?
Yeah.
Okay, so there is, Sam or Robin, can you provide Patty with the internet access for here? Yeah. So I think you have to go and guess Wi-Fi.
Yeah. Okay. Okay. Yeah. Okay.
the best way to log on is through LinkedIn. Because it's you do text on LinkedIn and Facebook.
Okay.
And LinkedIn's the one that you can go for most of the time because the signal's not the best.
Okay.
For your phone anyway.
All right. Okay. Great. Thank you.
Are we live, by the way? Oh, we're live on there. Okay, that's good. It's awesome. Okay, Robin's given me the nod and said, yeah, we're good to go. Okay. Close that door as well because I got his voices. Okay, hello and welcome to this Google Developer Group Milton Keynes meetup. Today we are going to be looking at how you interact with your documents. I've been reliably told that it's no longer with Gemini Pro, it's now with Gemma. Am I correct in saying that, Patty? Yep. So it's a different flavor of Google AI tech because they have a bunch of different flavors. So Patty will give you a little bit more information as into how they all work. For health and safety reasons, I have to tell you, if there's a fire or fire alarm or anything like that, please just head straight out, follow the green signs and make your way out of the building as quickly as possible. I don't think there's any schedule. No, I know that there's no scheduled fire alarms today. So here's what's coming up over this week. I need to get the slide changed. So Patty O'Callaghan is the technical director, the new technical director of Charles River Laboratories. And Charles River, just if you don't know, this is their website, and they are a medical pharmaceutical business which is based out in Massachusetts. And they do all sorts of cool things. One of the things that literally caught my eye earlier on was that they were doing some sort of a study into the way how long COVID affects people. So it was quite interesting to see that. So they talked about antibodies isolated from patients and so on. So Patty is now the new technical director, and she's been there for a number of years, I would say. Yeah, quite a while. So she's gone through different phases there, from software engineer to technical lead, now technical director. So she's seen how that business has changed over the course of the last few years. So there's nobody more skilled or experienced to tell you all about how this company in the US, the pharmaceutical and medical and healthcare business, is leveraging AI. If you wish to see any of the photos that we will take from today, please click on the QR code. It will show you all of the information. It'll show you all the photos that we've taken today. There's none in there as yet, but I will start taking a few photos in a minute and start populating that later on. And Patty, I'm hoping that there's going to be some slides that you might have that we can share later on as well. Okay, that's awesome. Slides and code, excellent. So we'll take some of those snippets and we'll get them up on there for you as well. Okay, so thank you very much. By the way, Google Developer Groups in Milton Keynes, it is a voluntary organization. It's here to try and help people learn and understand what's happening in the landscape, especially when it comes to Google technologies, but it's not exclusively Google technologies. There's many, many other integrations that you have with other types of Google tech. So yeah, please feel free if you would like to participate and take part and learn a little bit more about how the program works. It is here specifically for to help people understand and learn more. And the main thing is that you guys enjoy it. So we will continue to support this and continue to put on more events like this coming up soon. And you can find out all about it if you go on our GDG Milton Keynes website. So thank you for your support, and I'll now pass you over to Patty.
Yeah,
There you go.
I'm having still some issues to
Is it?
get the Wi-Fi connection. Trying to send in the email, but I don't have,
A signal.
yeah, to be
Mm,
able to log in. Maybe I can try with the
we try with the
DNS.
the SMS code.
I would go to LinkedIn. If you have,
She has tried LinkedIn.
Yeah, the thing that is sending a security check into my email, and I cannot, yeah.
it's a signal, there's a.
Do you want to try it with just the what you call it, the SMS text messages?
SMS, yeah.
Yeah.
Sorry about that.
It's okay.
Let's try again. Usually I have like very good reception in my phone. And
It's
I use it.
horrible reception here. It's a big Faraday chamber, so that's why.
Okay.
Yeah, it's a struggle.
All right. So what I'm going to do is that I'm going to try with the
SMS. Yeah.
And of course, I don't know my own phone number. I think so. You never. I have a very bad memory. Okay. Let's see if this works.
Fingers
Hopefully.
crossed. So it should ping your pin anytime now.
Yeah. Maybe I will need like to go outside.
You might need to.
Yeah,
I know
yeah.
it sounds really weird, but yeah, that's how we
Yeah.
do it.
Yeah, so I will need for you guys to give me just 1 second to go
Yeah.
outside.
I might have to
get
just
the
pop
key.
out and quickly come back
Yeah.
in.
Sorry about that.
Hmm?
You just want to hotspot you did. I can hotspot you from basic. So.
No, it's literally she'll
Let's
just pop
try it.
outside.
If
Yeah.
not,
Yeah.
then
Yeah.
well, let's see. There is always
A technical hiccup.
yeah, all the time. Yeah, it's like in the hotel it didn't have a good reception either. Is it a thing in the city or?
I think it's just in this particular building. So
Okay.
yeah, it literally comes through like as soon as you hit outside. Trying to kick it back into gear. Yeah. Just keep my cue up here.
All right.
Okay.
All right. Okay, we got it. Yeah, let's see if it works. And it doesn't say like time pass or anything. Okay, fingers crossed. Seems that we are logged in. Great. Yes, let me pull everything up. Just give me a second while it's okay. Yeah. And I'm come here. I'm going to silence this because my kids, they have this thing of calling me. It's kind of a family tradition now. They call me when I'm in the middle of a session. It's like they have this kind of radar. Okay. Okay, so while I pull this up, we were going to run the work with the Gemini. Yeah, I'm going to show it. We're going to run the Gemini Pro model, but we had some issues, like there was a change in the way that when we are coming to speak this kind of events, we always get Google Cloud credits to give to you guys, but there was a change in the process and I couldn't get the credits on time. But that is good as well, because we are going to learn how to use a framework that can allow us to run the large language models locally for free on our machine or laptops. So that's actually cool as well, because you don't have to pay for anything to run these LLMs. And we are going to use a model that has been created by Google that is called Gemma, and it's an open source model. So it's also free for us to play with it and to use it. Okay, so I'm gonna start sharing this, and everything ready? Okay. So let's see. All right, brilliant. And I'm going to do this over here in the full screen. Right. Okay. So again, the name of the title of the session is going to change a little bit, but it's still, we're basically going to do the same thing. We're going to learn how to use these technologies in order to be able to chat with our private documents. It's kind of, I don't like to do this analogy because it's kind of getting tiring and all, but it's, imagine that you have your own ChatGPT that you can use to ask questions about private documents that you might have, and you don't want to, have them for security reasons, maybe in your organization or the company that you're working on. You don't want to have those documents available for everyone, and also you don't want these models to be, available for other users to be querying and asking questions and getting sensitive information back. Robert did a great introduction, but I'm just going to go very briefly and tell you a little bit about me. My name is Patty O'Callaghan. I have a very, very Irish name, but I'm originally from Venezuela in South America. My background education is in computer science and artificial intelligence. So I studied AI almost 20 years ago when it was not popular. We were the nerds. Nobody liked us. People will ask us like, why are you studying AI? It was very academic. So now the time has come for the revenge, and now we are the cool kids. So that's actually pretty cool. As Robert said, I'm a technical director at Charles River Laboratories. We do really amazing stuff over there. I'm a Google developer expert in AI and machine learning. I'm also very proud of being part of Women Tech Makers, which is an organization, also a community program by Google, where we, create programs, support, mentorship for women and girls that want to join the tech industry. So I'm an ambassador for that program. I run the same community, but in Glasgow, GDG Glasgow. And the thing that I like the most to do is that I'm a volunteer teacher at Code Club, which is part of the Raspberry Pi Foundation. So basically what I do there is that once per week, I go to my local school and I teach kids how to code. And they're doing amazing projects with machine learning as well. So it's pretty, pretty cool. And if you want to get in touch with me after the session, if you have any questions or anything, you can scan that QR code and you will have like all of my social media, LinkedIn, and so on. And I'm super happy if you have any questions after this session to help you out over there. All right, so enough about me. we all know what is artificial intelligence, right? So let's do like a very brief overview of what it is. It's a field of computer science. Is actually quite old. Usually people that is not, working in the technical industry, they might think that is a new thing because, now it's being used more broadly for people everywhere. But AI started to be a thing and to be researched and to have really amazing applications back in the 50s or something like that. So it's a pretty cool area of computer science. And of course, the main goal is to make computers think, behave, reason as humans. And it's quite a challenge, but a very exciting one. So between all of those things that we do as humans that the computer science, like the AI field, wants to do is to be able to do for computers to do reasoning and problem solving. They're getting very good at that. We cannot get like, we could get into the philosophical discussion about if computers really reason like us, but we can say that they do in certain ways. Knowledge representation, planning, learning, natural language processing, which is very related to what we're going to talk about today. Perception, machine learning has gotten amazing progress in terms of perception and how computers can identify objects and like the surroundings around them, kind of the way humans do. Robotics, which is like my favorite part, and social intelligence as well. I'm not going to go into the detail of each of these because I think the most important thing in this session is to actually see the code working. So what is machine learning? Machine learning is a subset of AI. It's just that there is a bunch of other areas of AI that are doing amazing progress, but machine learning is like the most popular one nowadays, and the biggest is the area of AI that is having the biggest impact. So basically, with machine learning, we're looking for computers to be able to learn through finding a pattern in among data and also from experience, which is kind of the way humans learn, right? Basically, since we are born, we're learning patterns and we're learning how to react to them depending on the environment and so on. Computers are exceptionally good at finding patterns and recognizing patterns, and they are getting way, way better than humans at that, but way better. So that's exciting. So just to understand what is the difference between the traditional way we have been programming and what is machine learning, this is a nice way to see it. So if we are coding, let's say, I don't know, a Java application, we have data, we're coding our application or program. The computer then processes that code along with the input data and produces an output. In machine learning, it's a very different way of doing things. We have a bunch of data, right, that we can call the training data. We have the output, which is what we want to, let's say, identify with the machine learning application. We give that to the computer, and the computer will create what we call a model that is capable to get new data and give that output. But there is a really nice way to understand this. And I found this explanation, and here you can find the credit. I think this is brilliant. So this is a really nice way to understand this. So traditional programming could be like, okay, you want to cook a dish, right? You get the ingredients, you get the recipe, you follow the instructions with the ingredients, and you get the dish by the end. So machine learning is very different. You get the ingredients, and then you get the final result, which is the dish. And you give that to the machine learning, to the computer, to be able to find the recipe, right? And then that recipe will be the model. So every time you get new ingredients, the ones that you need, of course, is going to be able to provide the final dish. So this is a really, really cool analogy that explains the difference between the two ways of traditional programming and machine learning programming. Okay, so let's talk a little bit about the types of AI. It's also a very interesting thing to know because you will hear a lot some of these terms, and I'm going to explain one of each of them. So we can start with artificial narrow intelligence. So artificial narrow intelligence is the stage that we are in right now. So we can say, okay, it's machine learning. It's one area, one problem. So we have models that are capable of work very precisely in their own domain. Let's say the machine learning model that plays AlphaGo is really, really good at it, right? It's better than the best player of AlphaGo in the world. But you cannot take that model and use it to recognize, I don't know, recognize different kind of birds or stuff like that. It's not possible. So we have a bunch of models and machine learning applications that are really good in their domain. So they cannot generalize. So that is what we have right now. So if you hear artificial narrow intelligence, you might hear it somewhere, you know, in papers or in the news or whatever. This is the stage that we are right now. Then the next stage is artificial general intelligence. So we can say, okay, we can call that machine intelligence. And that is when we will have systems or machine learning models or AI applications that are going to be as smart as a human. And this is for me, it has been so shocking to start hearing these companies like Google, DeepMind, OpenAI, Microsoft, since maybe a couple of years ago, talking more about AGI, reaching artificial general intelligence. For me, when I grew up, that was a very sci-fi, topic that, and people, researchers, academics, they didn't take seriously researchers or people that would talk about AGI because it was considered that we were not going to reach that point in time of AGI. So just to have an idea of what did I mean by general intelligence is, as humans, we have the capacity of, we are learning something and we are able to generalize that thing that we learn or those experiences that we had in order to get to learn new information. So this is a simple example. Imagine that you're learning how to swim, and you're learning how to swim in a pool, right? So you go to your lessons, you're learning how to swim, not to drown or whatever, and then you get good at it. So you build up a bunch of knowledge around swimming. And then for the first time, you go to the beach and you get into the water. And it's a different environment, right? You now have new variables. You have like the waves and it's moving, so it's different. But you don't have to learn all over again. You can bring the knowledge and the experience that you got from the pool, and then you build up new skills on top of it that will allow you like learn how to behave in this new environment. So that is generalizing knowledge. You bring previous knowledge, previous experiences, and to help you learn in this new environment. So I think maybe 6 months ago, or maybe a little bit more, OpenAI, they publish a blog post in their website stating that they're actively looking to reach AGI. Okay, so that's kind of shocking, but it's cool. I mean, I'm excited, but there is a bunch of stuff that we need to consider in terms of ethics, data privacy, and so on. Then the next step, and there are amazing books about this if you are interested in the topic, is artificial superintelligence. So artificial superintelligence is the point in time where we as humans are basically done, because the computers are going to be much smarter than the smartest computer, right? And they call that, well, I say they, some researchers, no, it's like there is not an agreement around these definitions. Actually, I think it was back in December, Google DeepMind, they released this amazing paper where they actually describe several levels of AGI. And it was a paper that actually made sense. It's not a sci-fi definition of AI like or AGI. So I will highly recommend that paper as well. So artificial superintelligence. The machines are going to be much smarter than us. And we are not going to be able to understand what they are doing. And is a thing that for some researchers and some academics and some people working in AI, they are, I don't know if you have heard the term peak doom. They are saying that it's going to be the end of the human race, and they are giving like numbers. It's going to happen. I think it's going to be, I don't know, 99% of a chance that AI, as soon as we get to this level, we're going to get destroyed, and so on and so on. So that level, it has a name, and that name is called the technological singularity. So the technological singularity is the point in time where the human intelligence is going to be surpassed by AI, but like super fast. And because the evolution of human intelligence has been very slow compared to the evolution of how machines are learning, right? Because we have an organic brain, we're slow in terms of evolution, but AI is like evolving really, really, really fast. And there has been discussions like, as soon as we get to this point, machines are going to be able to replicate itself and to make themselves better. So for example, some researchers say that it's going to be like machines finding Nobel Prizes, like discoveries, like 5 in a minute. And we are not going to understand what those discoveries are about. So it's going to be, and it's going to go really fast. And we are not going to be able to pinpoint when the singularity happened. So it's a little sci-fi, but again, it's kind of weird to see all of these companies talking about AGI. But it's pretty interesting. I highly recommend you to have a look at it. It's quite a thing. For example, Stephen Hawking, he said that it could be like getting to that point could be the best thing that ever happened to the human race, because we're going to be able to find like the cure for cancer and stuff like that. Or it can be like the worst thing to ever happen to the human race. Then if we see like people are saying, yeah, we're going really fast towards the singularity. And this is, no, it's not outdated. This is how the research regarding to AI is going up through the years. The private investment in AI is incredibly high, and how fast it's going. So if you start putting together, all of these pieces, it seems, but it's open to discussion, right? That we are gathering like all of the conditions that we need for the singularity to happen fast, like closer and closer in time. This is another thing that we can consider. This is a metric on how a machine learning model can recognize, can answer questions about images, and is getting better than the human baseline. So for many metrics, computers are being way, way better or a little bit better than humans. But for other metrics, computers are absolutely dumb and we're better than them. So we have to keep that in mind as well. This is another one, a particular metric as well as how accurate these models are able to answer, academic questions or exams and stuff like that. This is pretty cool. So this is how the capabilities of these AI systems are getting better and better at recognizing images and language. And this is old. This is old in terms of AI time. It's 2021. Like right now we have so much better innovation. Like handwriting recognition is way, way better than humans. And this is the most important part. This is what is making everything possible. And it's the hardware that we have available right now, right? We have NVIDIA doing amazing stuff with all of these chips that allow us to, do the bunch of matrix calculations and difficult maths, and it's just going up. And this is why the improvements in hardware are making it possible to do all of the innovation that the researchers were thinking about in 1955. It's just that back then we didn't have the hardware to be able to prove those, ideas that they have. But now it's just going up. So it's pretty exciting times. So now let's start talking about a little bit about what are LLMs to understand what is that we're going to be doing today. So LLMs, basically, we have machine learning models that are capable to work. I don't like to use the word understand, but work with a lot of different content, text, video, images. They are training huge amounts of data, huge amount, like huge parts of the internet and so on. And they are basically deep learning algorithms. So this is how large are they. We have really, really huge models. Again, this is not updated, but also it's so difficult to give a talk about AI. I have to be updating like the slides every now and then, like almost every week. It's stressful. If you can see here, we don't have, for example, Gemini is not there. The Gemma models are not there. There's a bunch of new models that are huge and are really, really good. GPT-4 is not there because OpenAI they have not disclosed the size of the parameters. But yeah, as you can see, they're getting bigger and bigger and bigger, and that is because we have more computing power to train them. So let's think about how the large language models work. So they try to, with deep learning, deep learning, you have neural networks, and they try to imitate the way we have our neural networks organized. So we have a bunch of neurons, and they're connected, and there is a value that represents how strong that connection is, and it is called weights, okay? And of course, neurons that are connected, they can be related by some reason, some attribute. So in LLMs, the nodes are essentially words. We could say numbers, but let's keep it at words right now. And basically the model is you can have a bunch of words. Imagine a 3D space, and you have a bunch of words in that space. And the words that are related to each other are closer. So for example, if we say the word teacher and the word student, it's going to be closer because they're related, right? But if we say the word teacher and the word, I don't know, rocket, there's not a lot of connection, so they're not going to be as close. So that's kind of an abstract idea of how we can imagine how this is mapped. So for example, this, what happens is that if there is a string, it's going to be, divided by all of the words. So this is a very cool, I don't know if we can open it, way to see. Just to imagine how this works. There it is. It's just a simple example. So you can imagine a bunch of words in a 3D space, and those words are related to each other, right? Connected. And the connection is going to be stronger if they are, and if they are related, and the words are going to be closer. Okay, let's continue with this. And the thing is that what happens is that those words, imagine that they are in certain positions. So you get those words and you convert them into numbers, because computers, they just understand numbers, right? So it's converted into vectors. And those vectors are stored in a database, and that we can know by looking at those vectors, what is the word, how are they related, and how close they are. So I'm just going to skip this a little bit, just not to overwhelm you with the definitions. But for example, we can see here how words can be related. If we have a sentence that say, what is a tasty food to eat? A tasty food to eat is delicious. So we can relate tasty with delicious, and it's going to be closer. Okay. Okay, let's jump into what are we going to do today. So we are going to be using a framework that is called LangChain.js. So LangChain is a framework that allows you to create and develop applications that are powered by large language models, okay? And there is a version, I think the original version is in Python, but we're going to use the JavaScript one, because sometimes in this kind of meetups, we find more JavaScript coders, because there's a lot of people that is learning how to code. But there is also, if you're more comfortable with Python, there is also a version with Python. Okay. So basically, this is how it works. We can have different kinds of sources for our application. We can have unstructured data, which means maybe a PDF document. Okay. We can have code, and we can have structured data like a SQL database. And then we can have those data sources, and they're going to go through our LLM application. And then we can interact with that in many different ways. Maybe we can have, an application that suggests what's the next line of code that you can write if you're coding. But in this case, we're going to do like a chat application that is going to do questions and answers. So this is basically how the LangChain workflow is. We have the module, the library that loads the documents, and LangChain provides, features to load, for example, CSV files, PDF, a bunch of different kind of file formats. Then a splitting process happens. So we have the whole text. It can be the whole document, and it's split in chunks. And you can, depending on what you're doing, you can decide the size of that. So it's split in chunks, and then it's stored in a vector store with the embeddings that I told you, like the numbers that represents how the words are represented there. So this is an example of how the embedding happens. So we can have a bunch of objects, and then the embedding model, what it does is that it grabs that information and it converts it into vectors. And vectors are numbers, and numbers is what computers understand. So we're kind of translating this to the computers. It could be a word, it could be an image. Yeah.
well as images.
I guess you will need to do some pre-processing of the data before, like to extract the images and so on. And then, yeah, you will need to do some pre-processing. Okay, and this is a good example. Again, we have the numbers of the vectors there, and here you will see, like I told you before, like this 3D space with all of the vectors, and you can see clusters, and the clusters are like bunch of vectors that are related to each other by maybe they're the same kind of words or feelings or whatever you have on your data. Oh, okay. Didn't see that, thanks. Okay. Right. And we have here another example of how the sentences, let's say some strings, are evaluated and how they can be a part in this space. So for example, if we say a little boy is walking and a sad boy is walking, they're kind of related and they're together because they're similar. But if we think about, look how sad my cat is, it's completely unrelated. It's not related. But if we say a dog is walking past a field, it's kind of related because it has the term walking. So that's how it starts to spread in the area and the space that we have all the information. So after we have everything in the vector store, we have the retrieval. So there's a query, and the relevant splits are being taken out. And then along the prompt, and giving this to the LLM, it will provide the output, which is the answer. And we will see this happening. So what is that we are going to use? And I'm going to share with you the repo so you can practice this and play with this at home. So we're going to be using LangChain, all of those libraries, PDF loader, the text splitter, the vector store, the prompt template. I will explain to you each of those. Then we're going to use the Hugging Face transformers embeddings to create the embeddings. And SvelteKit is just a technology for dealing with the front end. So here, these slides are not updated, and they don't include Gemma, but we're going to use Gemma today. But what we're going to use first is Ollama, and I absolutely love Ollama. It's amazing. So with Ollama, you can locally run open source LLMs, and you don't have to do anything. You just have to install Ollama, download the model, and it's ready to go. It's absolutely amazing. I still remember when we were training like our first, neural network at uni many years ago. It was so complex, but now with these technologies, you can do, your own applications using LLMs so easily. So I just cannot wait. You don't have to be like a data scientist or have a computer science degree. You can just start like creating your applications. So at the bottom, you will see in the repo, we are using Llama 2, but in the example that I'm going to run, we're going to use Gemma. So for example, if you're using the models, that are evaluated by the size of the parameters. So for example, a model with 3 billion of parameters is considered small. There are models that has like 30 million of parameters. They can be huge, 70 billions and so on. So these are the requirements, the hardware requirements that you need in order to be able to run these models in your machines. You don't really need, like I can run it in this laptop, and the laptop that I had before that the hardware was not the best, and they can really run if you choose the smallest models. Okay, so this is I should have put like a QR code, but you can take a picture of this. This is the repo that has the code, and it has all of the steps that you need on the README file, all of the steps that you need to follow in order to make it work. But I'm going to go through them and explain to you each of the steps. And if you have any questions, you can completely like interrupt me, or if I'm going too fast or whatever. So I'm going to leave it like you can take a picture and we can continue.
I'm taking some pictures as well so that we have the same QR code.
Okay, great.
Would you like to set these slides?
Yes, the link to the slides is in the repo. So you will be able to take them from there. So I'm just going to go to the repo. I think it's easier to just get in, make it whole count. So here's the repo. You will see everything that you need, right? On the README file, there's like all the steps that you need to follow, and this is the link to the slides. I will try to update them because they're a little bit outdated, because in AI you have to update stuff like every 3 hours. This is overwhelming. One thing that I would like to mention is that the first version that I had for this workshop was way simpler in terms of the UI. But I have 2 friends, they have been contributing to the project, and also we have some issues that has been raised that are ready to work. So if you would like to work with an open source project, even if it's a thing that we just use for education, feel free to create a PR, have a look at these issues, and contribute to it. It will be awesome. Again, it's a simple application, but it's always good to contribute and work with other people. Maybe if you don't have working experience as a software engineer, or maybe you have a lot of experience, but you can contribute with open source, is always cool. So actually, I can see that we have 2 pull requests that I haven't merged. Okay, so let's see step by step. So the first thing that we need to do is to go to the Ollama page and download it. Luckily, very recently, they added support for Windows. And I say locally, but also I feel bad for those of you that have to use Windows. But it's okay. It's a life choice. I will not criticize you, but I just feel sorry. But yes, they just added the support for Windows. So basically, you just download the file that is a downloader file. You execute it, and it will install Ollama on your machine. I have it here. Here at the top. Okay, so after you do that, something that is very important as well is that you need to have Node.js running, right, locally on your machine. So you can go to, actually that's the first step. You go to the Node website and you can download Node.js. Do you know what is Node.js, or do you have any idea? So Node.js is an application, it's a framework that it's a runtime environment, but let's say that it's a framework that will allow you to run JavaScript applications locally on your machine. It's kind of a runtime environment. So you will not need to host your project in a server elsewhere. You can just run it locally. So the first, and because we're working, this Node.js is for JavaScript applications. Since we're going to be working with JavaScript, we need to run Node. All right. So I already have Node on my machine. I already have Ollama. You just have to follow the steps. It's very, very easy. And then what you have to do is that you go and download the model that you want to use. So let me open my terminal, and I will show you what we're talking about here. So I already have, make it bigger. I already have Ollama installed, right? So if I just write Ollama, I can see all of the options that are available. So I can start the Ollama server, I can create a new model, I can show the information for a particular model, run it, I can pull models from the Ollama registry, so it's super easy. And I can also list, all of the models that I have locally and so on. So for example, if I run Ollama list, these are the models that I have right now on my machine. I have Llama 2, I have Gemma, I have the Code Llama, which is allow us to, it's a LLM that is fine-tuned, is specialized for coding. So it's very good for coding tasks. And Llama 3. If you want to know what are the models that are available, you just come here and you will see the list of available models. Come on. Okay, so you will see there is a bunch of them. Some of them are specialized, for example, for medical applications. Others are specialized for particular languages. I mean, like, not programming languages, like maybe there are specialized in Spanish or in Chinese or whatever. The Mistral models that are very, very good. Gemma is the one that we're going to use. So you can come code Gemma is the one for coding. So you can come and play with them. And let's say that I want, just to show you, maybe I want to download, I'm going to pick one that is small. One that is, because it can, okay, I'm going to download this one. So let's say that I want to get phi 3. So what I do is that I go here and I say Olama, pool, phi 3, and I will start downloading the model. And then I will have it available. And that is it. Super, super easy. Okay. So while that is being downloaded, and we don't have the best connection, what you have to do then is clone the repository, right? As soon as you clone this repo, you can start playing with the code. The first thing that you have to do is run npm install. Have you worked with npm before? So npm is a package manager for JavaScript libraries. So you go to npm and you can find a bunch of different stuff that is already done and it's ready for you to use in your project, so you don't have to code stuff that is already there, right? So it's a good practice not to put the code for each of these packages in a repository because they can be quite big. So what you do is that you have a list of the packages that you're using, and when you run npm install, it would go have a look at that list and start downloading the stuff, the modules, into your laptop or your computer. So you do that, and then you run npm run dev, and what it will do is that it will spin up the server, and you're going to be able to interact with it. Have you worked with Git before? GitHub, a little bit. If you don't know how to clone a repo is basically a place where you put the code and you can share it with people if you want, or you can make it private. If you don't know how to use Git, I will highly recommend you for you to learn how to use it. It's quite simple. Well, sometimes it can get like some Git nightmares sometimes, but it's easy to learn. But if you don't have a GitHub account yet, or you don't have Git running in your machine, you can just come here, click code, and click here and download zip, and that will download the project into your computer. Okay, so I have the project here, and first let's see it running after I go into the code. Hopefully that you can see that correctly. And all right, so I have the model now, and let's go to npm. I don't have to run npm install because I already have it. I already have it. I have the packages. Okay, so I'm going to run npm run dev, and that will put all the project into the local server. So it's going to be hosted here. And I think I changed something. Yes. I was showing, my husband is a urologist and he works in the NHS. And I was showing to him how we can use something like this in his urology department. And I was like just showing to him like, yeah, you can do this. Yeah, the Air University Hospital, that's where he works. So this is not what you should be seeing. Like this had a name like Nodebot or whatever, but I was just changing the code and I forgot to put it back. But let's imagine that that has another name. The application can have another name. We can change it very easily. So There are three kind of things that we can do with this application. We can just talk to the LLM, and right now we're using Gemma. You know, the way you talk with ChatGPT, ask questions. So we can go choose this option. So let's see how it works. So yes, the Eurobot. Imagine that it has the GTG Milton Keynes bot or whatever. Yeah. Okay. So I can ask like, what is the capital of Venezuela, which is my country? And everything is running locally, right? So the query is being asked locally in my machine to the model that I downloaded. In this case, is Gemma. So I can actually disconnect the computer from the Wi-Fi, from the internet, absolutely no internet connection, and it will work the exact same way. So this is pretty cool, because you can think of ways of, you know, maybe, and now we have models that you can use them in the mobile phones. So you can actually have something that can be helpful even if you don't have an internet connection on your phone. It's pretty cool. Okay, so we can have this. We can keep on asking, like, you know, questions that might be more harder than what's the capital. I don't know. Tell me the story of Cinderella, whatever. I don't know. And then it will start like saying a bunch of stuff. So you see, it's pretty fast as well. It's to be something that is running locally. So we have the chat, then we have the URL. So the URL is also a very interesting use case, because basically what you can do here, and it doesn't show too much because the UI is too dark, but you provide an internet URL. For this, you will need to have an internet connection, right? You provide a URL to a website, and you can ask a question about that website, okay? So when we were chatting, the model has been trained, right, with a huge amount of data. So when we are chatting with the model, it's retrieving that data that it has been trained on. But when we are referencing a URL, it's grabbing the information from that website, and it's going to retrieve the information from that website specifically. We have to be careful here, because a lot of websites, they have you know, protections against bots, and it might recognize that as that request as a bot, and then it will block it, and you will not get a response back. So that doesn't mean that it's not working. It means that it's just that the server is recognizing this request as invalid and it's blocking it. So let's think about a page that probably doesn't have that issue. What was the one that I was using the last time I did this? Okay. What is the, do you know the, okay. So it will be this one. This one? Okay. So let's see. We copy the URL, we put it here, right? And then we can ask the question. So we can ask, for example, what is the MQU? MQU. And let's see what will happen. So I will submit it, and it will go there, and that's the response that we're getting. So let me make this bigger. I think that's better.
So it's looked at the URL and the data that's in the URL, but then responding using the Llama, which is installed in your system.
It's doing like it's using the training that the model is capable to reply questions, but that is given a context. So it's going to this website, it's grabbing all of the HTML information, and it's using that as context to reply. And I think it did a good job. Yeah.
So the model is the pattern matching based example here. That example you showed earlier the weights of words and shows the relations between them. It's used that system of modeling on the data.
Yes, exactly. Yeah, exactly. So it's using that everything that it learns in how to, relate words in this huge pool of data, and is using that along this context to grab this new set of data and use this knowledge to be able to reply like this.
Is its model updated as a result?
No, no, and that is very important because, for example, sometimes for companies, they want to implement applications using LLM, and maybe their security teams will say no because you might bring information into the LLM that might be, used as an output later on, but that is not the case. And for example, you have to be very careful when you are dealing or interacting with a product that has an LLM, because sometimes these companies, certain companies, can use that information to retrain the models. So at the beginning, when ChatGPT started to be like a big thing, there were instances like they were actually doing that, and there were instances. There was a very, very popular incident that happened with some engineers on Samsung, that they actually provided into the query sensitive information that was then used as training data, and then it was appearing in output. But in this, we're not doing that right now. So that's an important thing. Another important thing that I would say is that it's very, very, very important to never, ever, ever trust like blindly what you get out of an LLM, because LLMs can be wrong. They are getting better each time, but they can still be wrong. And actually, that is called hallucinations. So if you hear like, oh, the LLM is hallucinating, it means that it's giving an answer that sounds very convincing, but it's absolutely wrong. So that happened with me. That happened to me with my daughter. Some weeks ago, she was studying for a math test, very important. And I was helping her, and we were kind of stuck in a math problem. And just for fun, I told her like, "Oh, Julieta, let's ask." I think we used Gemini for that one. I don't remember. So we wrote the math problem, and it replied like step by step, really convincing. It sounded logical, step by step, but I read it and I was able to realize that it was absolutely incorrect, but like absolutely wrong. And I told my daughter, "Oh, whoa, this is so wrong. This is bad." And of course, I was able to recognize that it was wrong. But my daughter, maybe if she was studying with her friends, maybe they will not be able to recognize that. And it sounds logical, and then it will have been a mess. So you have to be very careful, very, very careful about trusting what you get out of an LLM. Always double check all the time. All right, and then the third feature that we have is the files. So the files is basically the same idea. We get a PDF. It can be a CSV file. It can be an Excel file. It can be any type, a lot of different types of files, and we upload it, and the application will do the same. It will scan the content, use it as a context, and reply. So let's see what we can use here. A bunch of stuff here, but okay, this was the one that I was testing with my husband. So this is an NHS, document, and I believe this document is like 170 pages long. Okay, so I'm gonna use that one. I'm gonna update it, and I can ask a question. Write a summary about the NHS long-term plan. I will submit it, and it will do exactly the same. It will get all of the information, it will convert it into vectors, it will do all the stuff, and it will reply and write a summary about it. So as you can see, again, quite fast. 170 something pages long. And this is a summary of the document. And we can ask more specific questions about it. So if we're using a model that is fine-tuned is kind of a way to say that it's retrained. It's fine-tuned for coding purposes. We can give it, a whole code base, and we can ask things about the code base. And that is actually a pretty cool use case because, sometimes you're joining a team and you're joining a project where the code base is like super complex, and you can spend it can be a nightmare. You can spend, weeks and weeks trying to understand what is happening there. And maybe you get, you ask the seniors in your team, but they are busy as well. So using these models, you can, get information back so quickly. Of course, you have to double check, but it's still going to save you so much time. It's amazing. Okay, so this is how it works. So now let's have a look at the code. One thing that I would like to add is that the code, it has started being quite simple, but it's using this really cool UI. So you will see a bunch of, things about the front end and, the styling of the application and so on. But what I really want you to have a look at is at this directory here, which is the roots directory. So here we will see the API calls for the chat feature, the file feature, and the URL. So let's have a quick look at that. All the rest of the files, if you see that they are end with Svelte, these are just the, it's just the UI. So for example, here is where I change, I am Eurobot, but I can change and put, I am EDG Milton Keynes. And, I can change it in a bunch of places. And if I refresh here, you see it's right away. So yeah. Here is where I say, okay, these are the files that I'm going to upset in terms of the HTML tag. So I'm not going to go into the detail of the front end. But again, if you're going to play with the code later, you can contact me on LinkedIn or Twitter or whatever, and I can help you out if you have any questions. Okay, so let's have a look at this. This is the simple use case, which is the chat. So this is why LangChain is so amazing. It's so amazing. So we have the libraries for Svelte Kit is what we're using for the front end. Then we have the library to deal with Ollama. Ollama, the framework that we're using to bring the models and make them run locally. We have runnable sequence. Let's say it's the library that allows us to run atomic tasks in the whole process. And then the parser that will allow us to, give the proper output in the proper format. So what we're doing here is that, do you want me to make this bigger? Oh, this is fine. We're doing a post request to our server, right? So we are writing a question and we want to post that question into the server. And in the server, we have the model waiting for the input, right? So that's what we're doing there. We're posting the question, right? We put it here. And then we're going to create an instance of the model, okay? Of Ollama, sorry. And that will be the model. So for Ollama, we say, okay, the URL is this one, and this is the model that we're using. So right now I'm using Llama 2, but if I change this to Gemma, I just have to change it here, and it will switch the model, right? And remember, you have a list of available models ready to go locally with Ollama. You just have to change it here. And if you go here, I have to open a new one. It's a new tab. And I go Ollama list. If I just use Gemma and the 2B, it will show that one, okay? So we just have to switch that there. Then what we're doing is that we get the information for the model that we're using. We're saying, okay, we are going to start preparing the output and to parse it. And line change is kind of chaining execution of little tasks, let's say it that way. So we're having everything ready. And then when we have the model ready, in the chain, we pass the question, and then we get the response back. And the response, we turn it into a JSON object, and it goes into the UI. It's as simple as that. It's just LangChain provide us with everything that we need to just create a request, pass the question, create the chain, and invoke the question and get the answer. So that's for the chat. Is there any question? Yes.
So basically, we have two servers running. Because we have the application, the chatbot application running, and we have the what's called LangChain server running and stuff.
Yeah. So we have two services. We have the one that is like the model is listening and waiting, and then we have the other one that is the application running. Is that your question?
Yeah. So the application depends on the other server.
Yes, because that is where we have Llama running the model.
You can swap out Llama 2 or
Yes.
it's pretty much on the fly.
Yeah.
When it comes to that, is there any like I'm just thinking people will use that potentially just to see whether that model performs better.
Yes. Yeah, you can. Well, if you go to Hugging Face, for example, and there is a lot of places where you can actually see the metrics and how, like performance metrics, and how some, models are better than others depending on the use case. But it's also important for you to test it locally, because maybe your hardware, depending on your use case, one model is going to perform better than other. So, yeah.
Also, is there a cost efficiency ratio? Because a lot of places now are talking about sustainability and all this.
Yes.
Like, hey, which one is going to be like, I guess, the best response or the least power?
Yeah, that is. There are actually really nice, research that is being done around that. But, for example, I would need to like sit down and think what is the process that I have to follow in my machine to know which one is better in terms of because there are so many variables that you have to consider, right? But yeah, definitely. And stuff like how these models were trained, some of them, let's say GPT-4 or the one that OpenAI is currently training, that they haven't said if it's GPT-5. They're currently training a big model, and the amount of power and computing power that it needs, and the hardware, and keeping the hardware cold is huge. It's super huge. So that is a concern, right? So then you have people saying, it's okay, AI is going to be able to find the solution for climate change. So it's like, okay, we ruined the planet just to, realize, like, to be able to discover how to heal the planet. But, you have to be very careful, because in my perspective, AI will really bring amazing progress, and it will really help us find answers and solutions for tricky things like cancer and other kind of problems in a very effective way. But it can also be used for horrible stuff. So we're living in very interesting times. Okay, so we have that. Then things are going to get a little bit more complex, because now we have to deal with the documents, right? Before, we were just asking the model. So we were just using the model the way it is. But now we need to use additional libraries because we are getting a file. So let's see how this works. We have we have here what we're using to handle the request and the JSON objects for the question and the answer. Then we're loading different libraries for different types of documents. So in this case, we're using PDF loader, CSV, docx, which is for Word, and a plain text file. Then we have the library for the vector stores. Remember, we're storing the vectors there. We have a llama. We have a library for prompt templates, and I'm going to go to the prompt template as I go to the code. We have the runnable library, the parser. We have the one for the embeddings, to create the embeddings, and that is from Hugging Face. If you're interested in machine learning, I will highly recommend you to go and have a look at Hugging Face. It's a site where all the machine learning community contributes. You will find open source models, you will find open source data sets, tutorials, competitions. It's amazing. Competitions, you find them in Kaggle as well. But yes, Hugging Face is super cool. And then we have this library that format the document as a string. So what we're doing here, again, we have the post request. We have a form, and the HTML form has a file field to upload the document, and then the other field that is to write down the question. So we have those two fields. And then we're saying, okay, these are the file extensions that we're going to work with if we want, PDF, CSV, and so on. And then what we're doing here is that the file is being loaded over here. Well, there are additional stuff like to deal with the extension of the file, to check if it's within the allowed types of files. Then we load the file. And then I'm just going a little bit like an overview. Let's say we have all the files in this object over here, and then we create the vector store. So what we're doing is that we're using the embeddings function with all documents, the documents that we loaded, let's say one document, and we are putting the result of that in the vector store. And then we have a retriever, and the retriever is the kind of the object that is going to interact with the vector store and get the information out. Then we have a prompt template. So the prompt template is really cool. Working with prompt templates is really cool. So a prompt template, what it does is that before asking the question to the model, sending the question to the model, we can provide some context and then the question. So what we're doing is that it doesn't matter what the user writes, we are getting sure in the background to prepare to make the question, the prompt, because prompt is what we call the questions that we do to LLM, to make the prompt better and in a more optimal way to send it over to the LLM, right? And we don't want to write that each and every time. We just can't have the prompt in our code, and then the context will be part of the question of the prompt. The context is the document, and then we put the question of the user, and that is the prompt template. Sometimes you would like to create prompt templates depending on your use case as well. And then again, the same thing. We have the Olama, we create an instance of it. We have the runnable sequence, the chain, we add the question, and then the response. We get the response back. So that's basically, as you can see, we're doing some additional steps. Okay. And for the URL, it's basically the same. With the difference that in this case, we are not dealing with documents, but we are dealing with a website. So for that, we use this library that is called Cheerio. And what it does is that it goes to this website and load the document, like the text from there. Then we have the text splitter. What it does is that it will split all of the content for the website that we are having a look at. Then we have, again, the library for the vector store, and the rest is the same. So the only difference here is that we are going to go to the URL that the user is providing through the UI. We're going to load all the content that is in that particular URL. We're going to split it in order to be able to put it into the vector store. And then the same. We have this retriever, we have the prompt. We again are saying, okay, you are going to answer this question only based in the context of the URL, and then you provide the question. And again, you do the chain, and it's the same process as before. So these are the 3 different ways that we can work with this use case. And that will be it. The rest of the code that you will see there is, again, is about, the front end part of it. And if you want to know more and play more with this, the documentation of LangChain is really, really good. I'm going to show it here. So for LangChain.js in this case, you will have the documentation over there, and you will find everything that you need to know. I always recommend to have a look at the documentation. You can find the tutorials. So it's basically what we have done here today. And yeah, and that's it. So thank you very much. And if you have any questions, this is the time to do it. Do you have any questions?
So I was just curious, sorry, I missed what you were showing. Is this basically like a script on how to, so when it's posting the question, you're using the model on, for example, create a new instance of the model that you've defined.
Yes.
Going to a website, for example, using that as the data source, answering a question in that context, and posting it back to you. So this is like a script then to automate all of this.
Yes, because that's what LangChain helps you with. Olama will help you to serve the models, download the models and serve them. And LangChain provides you the framework to be able to create, to interact with the, with the URLs, with the document, or whatever you want to do with your LLM-based application. And then you can do a bunch of different stuff. Interact with the vector database and so on. I know that it might be a lot for a session, but it can give you like a kind of an idea of what you can do. And again, you can go to the documentation and start playing with this code. You play around and you see how it works. You play with different models, and that's how you can start like getting all of the knowledge and the skills that you need to start like building up your own LLM-based applications.
And just another thing out of curiosity, in terms of models themselves, open source, can we look at the code for those, or the source code available?
No, because the models, they don't have they don't have a source code. So the models is just a bunch of weights, a bunch of numbers that has the weights. Do you remember what I said about the weights? So that's what you get from the model. You will not see like some models, they can tell you, okay, this is the data that we use to train the model. This is the way we train the model, but the model per se is just kind of, let's say that you're using a binary file, that you are executing it. You're not going to be able to see any kind of code if you open it on a text editor. So yeah, so that's the thing. Yeah.
Just a weird question. How long would it take to train such a model, like the small one that you got? How long would it take to train?
To try?
Train.
Oh, to train. Well, it really depends. It really depends. Depends on the size of the data set, depends on the hardware that you have.
So this is a low. So I'm guessing it's quite small, like 4 gigs.
Yes, I think so, yes. It's just that I don't know. It depends in so many different things that is given a. So this one, for example, Llama 2 is 3.8 gigabytes. So how, I really don't know how to answer that question because there's so many different variables in there.
And is it self-correcting as well? Can it self-learn?
No. To do that process, you have to do additional stuff. You can fine-tune the models. Fine-tuning is, putting additional layers of information on top of it that will allow you to give a more specific responses depending on the thing that you want to add on. But when you're using this, you're not doing any kind of retraining of the model. It's just you're getting stuff out of it, and you're using, for example, with the document, you're giving some additional context. But the content of that document is not going to affect the weights within the model.
Right. Once you compile the model, it's fixed.
Yes.
So if you wanted to update it, you have to recompile.
Well, recompile is, but it's a good analogy. Yes, you have to do a process that is not going to do the whole thing again. It's just that you're going to add some layers on top of it. That is going to make it more specific for a certain data that you want.
If you wanted to remove certain, let's say, like ratings, connections.
No, you can't. No. Yeah.
You could only.
Yes. Or you can train your own. You can train your own model. That is actually a pretty cool. I am more than happy to run another session where we can train our own model, and it's pretty cool. It's a really nice thing to do. Yeah, we can do it.
Yeah, because I don't know enough about it. Yeah, I would like to.
But today you learned something, right? That's good.
So for a long time, I remember like neural networks with all the terminology they use. Feed-forward neural networks.
Yes, backpropagation. Yeah.
You're right. 10 years ago. It's interesting how it's coming up again now.
Yeah, because it's the basics of this technology has been around for decades. Backpropagation, like all of that. There was a really important paper that came out about transformers. It came out, I think, in 2017 that changed everything in terms of LLMs. But it's still deep learning models. And we can run a really nice session using Keras, and we can create our own model and train it, and it's pretty cool. We just have to schedule it. But more than happy to come down and run it. Any other question?
One thing I was just going to ask about,
Yes.
access to slides.
Oh, okay. I will fix that. I will make them public. So.
If you go on share.
Yeah.
Checklist.
There you go. Anyone with the link? There you go. You should be able to see it. I'm going to update them because they're a little bit outdated. But yeah, I mean, not too much, but I have to update them. All right. Anything else? Great. Well, thank you for joining. I hope that it was useful for you. And again, if you need any questions, if you have any questions, comments, whatever, you can reach out to me and I will be super happy to help. Thank you. Thanks. All right.